Has the pace of China's fifth-generation fighter development surpassed even the most optimistic external projections? As the New Year's bells rang out, China's two aviation giants, Shenyang Aircraft Corporation, SAC, and Chengdu Aircraft Industry Group, CIG, unveiled a series of hard-hitting announcements, showcasing a remarkable New Year rhythm to the world. This was no mere aircraft display, but a meaningful combination of moves that clearly outlined the grand blueprint and resolute strides of China's air power modernization. Shenyang took the lead, bestowing the honor of the first flight of the new year upon the J-35. On January the 6th, two J-35 fighters, painted in green primer, soared from the test runway one after another, completing their highly significant maiden flights. This move itself sent a powerful signal. Looking back over recent years, Shenyang Aircraft Corporation's New Year maiden flight missions were typically carried out by the J-16 fighter. This year, however, the spotlight shifted entirely to the J-35 for the first time, clearly announcing that this domestically produced fifth-generation carrier-based fighter has fully transitioned beyond its initial development phase and entered stable, mass production. Subsequent footage revealed multiple J-35s at different production stages appearing on the same site, vividly demonstrating the production line's fluidity and efficiency. The successful mass production and carrier deployment of the J-35 directly relates to the generational leap in the core air combat capabilities of China's naval carrier strike groups. It signifies that the Chinese Navy has taken a crucial step from existence to strength in building a stealth carrier-based aircraft force capable of countering the US F-35C. While the J-35 was dominating external discussions, Chengdu Aircraft Industry Group delivered an even more impactful visual bombshell, with a later-to-market first-to-market approach. A series of high-definition images showcasing the latest J-20 variant were released simultaneously. The footage depicted multiple J-20s either undergoing inspections with yellow primer or soaring through the skies during test flights. The most striking detail, however, was that every J-20 featured in these images bore the signature thick neck characteristic, a pronounced bulge and thickening along the fuselage spine behind the cockpit. This feature is the most distinctive visual identifier of the major upgrade variant widely known as the J-20A. In the highly standardized, mass production model of modern aviation manufacturing, it is extremely rare for multiple variants, with different structural configurations of the same series to appear simultaneously on the production line. Therefore, the uniform presence of thick-neck J-20A fighters in Chengdu Aircraft Industry Group's released footage effectively conveys a key message to the outside world in an unspoken manner. The production line for the earlier baseline J-20 has completed its historical mission. All current production resources and manufacturing processes have now shifted to the more capable J-20A. This is not merely a model iteration, but a declaration of comprehensive combat capability enhancement. The J-20A's thickened neck design is not about cosmetic change, it conceals profound evolution affecting the aircraft's core systems. First, the elevated dorsal structure significantly increases internal volume. This valuable additional space holds immense strategic value. On one hand, it accommodates greater internal fuel capacity, directly translating into expanded combat radius and endurance, critical for J-20 missions requiring extended maritime deployment and long-endurance operations. Second, the increased space provides the physical foundation for installing more powerful and complex airborne electronic warfare systems, new cooling equipment, and even sensors for potential future upgrades. This substantially expands the fighter's integrated avionics potential and mission flexibility. Third, this external modification is the result of meticulously calculated aerodynamic optimization. The redesigned fuselage transition curves more effectively smooth out shockwaves generated in the transonic range, reducing wave drag. Analysis indicates its transonic drag coefficient is approximately 10% lower than the base model. The direct benefits of reduced drag extend beyond increased range, manifesting in enhanced high-speed maneuverability and acceleration performance, further solidifying the J-20A's dominance in the supersonic domain. The engine, the heart that determines the top-tier performance of fifth-generation fighters, is the core highlight in the J-20A's evolution. Although the publicly released images do not allow us to verify the details of each J-20A's exhaust nozzle individually, considering the publicly acknowledged milestone advancements in China's aviation engine sector, it is certain that the WS-15 high-thrust vectoring engine, custom designed for the J-20, has entered mature mass production. Some newly delivered J-20As have likely already been fitted with this Chinese-made powerplant. Even if certain batches continue using the high-performance WS-10C as a transitional engine, the full transition to WS-15 engines is only a matter of time. The WS-15 delivers transformative capabilities. Its maximum thrust of 18.5 tons and thrust-to-weight ratio exceeding 10 enable the J-20A to sustain extended supersonic cruising without afterburner, with cruise speeds expected to stabilize above Mach 1.8. Beyond the fundamental transformation of its airframe and powerplant, the J-20A achieves simultaneous leaps in mission systems and stealth maintainability. The electro-optical targeting system beneath its nose has been significantly enhanced, with the optical window upgraded from the earlier 5-panel design to a more comprehensive 8-panel configuration. This provides a broader, blind spot-free situational awareness and targeting field of view, with its multifunctional integration reportedly surpassing that of the U.S. F-35's equivalent system. This highly integrated system enables the J-20A to seamlessly transition between air superiority, precision ground attack, and maritime strike modes. It has evolved from a dedicated air combat weapon focused on seizing air dominance into a versatile tactical strike node capable of both breaching enemy defenses and conducting sweeping operations. Furthermore, the J-20A incorporates a new generation of composite stealth coatings and airframe structural techniques. The new coating not only enhances radar wave absorption across all frequencies but, more critically, significantly improves reliability and maintenance friendliness. A more durable, easier to maintain coating translates to shorter maintenance cycles, lower maintenance costs, and higher wartime availability, factors of immeasurable practical value for sustaining the continuous combat effectiveness of a large stealth aircraft fleet. Shifting focus from individual aircraft performance to the broader production and deployment pace, Chengdu Aircraft Industry Group's capabilities are equally impressive. Multiple J-20A variants in their yellow test livery undergoing factory test flights simultaneously, coupled with official disclosures of intensive multi-location, multi-aircraft flight operations and multi-mission collaborative test flight modes, all point to one fact: J-20A production has established a high-speed, stable, and mass production assembly line rhythm. Comprehensive analysis of various sources indicates its annual output is steadily climbing toward a new peak, with reaching nearly 100 units per year no longer a distant goal. At this pace, it is entirely feasible for the PLA Air Force to add over 100 powerful J-20A fighters to its fleet within the next year. Projecting this trajectory, the total number of J-20 series aircraft in service is expected to surpass the 500-unit milestone in the near future, establishing it as an absolute mainstay capable of reshaping the strategic air power landscape in the Asia-Pacific region. This wave of modernization comes at a critical juncture. The PLAF's aging fleet is entering a peak replacement phase. The J-7 has fully retired from service. Early batch J-8s, J-10s, J-11s, and imported Su-27SKs and Su-30MKKs will also gradually exit frontline combat roles in the coming years. This will free up substantial organizational structures and resources, urgently requiring advanced fighters to fill the gap and ensure seamless combat capability continuity. The complementary pairing of the J-20A and the carrier-based J-35 fighter, combining high-altitude and low-altitude capabilities with light and heavy variants, precisely forms the backbone framework of China's fifth-generation naval and Air Force aircraft system. The J-20A, with its extended range, greater payload capacity, and superior overall performance, serves as the high-end punch within this system. It is tasked with seizing air superiority in critical airspace, penetrating dense enemy air defense networks, and striking high-value strategic targets. Meanwhile, the J-35 leverages its carrier-based flexibility and numerical advantage to function as the airborne shield, an extended strike arm of carrier strike groups. Complementing each other, they jointly underpin China's offensive and defensive air power framework in the era of fifth-generation fighters. Thus, returning to the initial question, the answer is now clear. Through this wave of official announcements, Chengdu Aircraft Industry Group delivers a clear and definitive answer. Production of the base model J-20 has concluded, with the production line now fully dedicated to the more advanced J-20A. This represents more than just an iteration of a fighter model. It marks a historic turning point in the development of the Chinese Air Force's stealth fighter fleet, shifting from addressing basic needs to pursuing excellence, and from establishing initial combat capability to achieving large-scale, systematic deployment.